Hey, thank you so much for having me. So today I'm going to give a talk on TypeScript called Nothing Generic About It. How do we switch to my screen as opposed to me? Thank you. Cool. Cool. So today's talk is called Nothing Generic About It, and it's about kind of generics and intermediate features in TypeScript. So who am I? My name is Matthew Gerstman. I am a software engineer at Dropbox. Dropbox has been using TypeScript since, I want to say, 2014, so we have a lot of experience with it. I live and work in New York City, which I love, even though it's not doing so hot right now. When I go outside, I have this great face mask that you can see. It is of just, a face. People like it. But yeah, you can find me on Twitter at Matthew Gerstman. That's usually the best way to contact me when I'm not giving a talk, and you can find these slides at generics.matthewgerstman.com. Now, I kind of want to call out, this talk is very much a spiritual sequel to a different talk I used to give called TypeScript Seeing Past the Hype, which is very much the pros and cons of TypeScript and why you might want to use it and how it gets in your way. This isn't really an intro to TypeScript talk. This is a let's cover the intermediate features of TypeScript talk. So I'd kind of like to frame it with some questions you've had. Unfortunately, there's a little bit of a delay between me and you in the stream, but I don't really have the luxury of having live interaction from all of you. So the best we can do is the All the Talk Slack. So if you are in the Track JavaScript channel, could I just get several people are typing right now? Just anything. I don't care what you type or what you say. It's kind of the best way for you to react to me. So there's about 10 seconds between you and me. So if something resonates with you, please, just several people are typing, respond to GIFs. I enjoy it. So let's cover some questions you might have had when you're working in TypeScript. How do I create a function that returns multiple types? Feel free to just start typing if you've asked this question. How do I get the type from inside of a promise? Can I use different types based on some kind of state? How do I tell TypeScript that I know something is wrong? And then finally, how do I type the shiny new JavaScript pattern, right? Like, who remembers HOCs and React? Those were a nightmare to type. And then render props got a little bit easier, and now fortunately hooks are very easy to type. But these, it's kind of, we have to keep up with these patterns and figure out how to type these things. And when you're first getting into TypeScript, one of the first things you learn is that you can use any, which you are initially told is, trust me, I know what I'm doing. By the way, if you are a Doctor Who fan, please just type in the Slack about Doctor Who. It makes me happy. So it's very much, don't worry, trust me. But it's less of a trust me, I know what I'm doing, and a little bit more like a trust fall, right? You learn that pretty quickly. You need someone there to catch you, because in any will start propagating through your code base. And shortly after that, you learn it's not actually a trust fall. There's no one there to catch you. Any is just going to start breaking things. And the reason for that is because any is a lot less like saying, hey, TypeScript, trust me. It's a lot more like saying, hey, TypeScript, turn off as far as this variable is concerned, or this argument is concerned. So the first thing I want to tell you about is any's twin, which is unknown. I like to say that any is the evil twin of unknown. So what exactly is unknown? Unknown is the set of all possible types. And the reason I bring it up is because a lot of the time you're using any when really you mean, I don't know what type to expect here. So unknown is this option where you can say, hey, this could be any possible type. We're going to figure that out. I got this slide from LogRocket. It is the only slide on set theory. If you pull up these slides, you can click on that. But don't worry, we're not going to cover set theory today. Now, unknown has some interesting properties. First of all, it has a value. So it's not like a valueless type. It really does have a value. Any value can be assigned to unknown, but we have to determine the type of it at runtime in order to start doing stuff with it. And I'll show you what the ergonomics of that look like now. So let's say I have a function which takes x, and x is of type unknown. If I try to set a number to x, it'll complain that unknown is not assignable to type number. If I try to do x++, it's going to complain about arithmetic. And if I try to do x + 7, it's going to complain that an operator won't work on unknown. But the second I narrow down the type, I can do all these operations just fine, because now TypeScript is aware, hey, this is a number. But that was just a number, right? Like we have a simple check for that. What about more advanced types? Well, we do that with a process called type narrowing. So what is type narrowing? Well, we have all these dynamic checks in our code that can give us information about values at runtime. Type narrowing is the process of reflecting this information in the type checker at compile time. So my goal today is to give you the tools that you need to reflect this information in the compiler. I don't expect you to memorize all of this or really digest and just like internalize everything we're going to talk about today. What I really want to do is give you a lot of tools that you can Google in the future so you know roughly, hey, I need to go solve this problem. This is the thing that I need to go to do it. But before we cover any of that, we have to talk about the fact that TypeScript is a structurally typed language. So what does that mean exactly? Well, if I have two types, I have a person and an elf, and they are structured the same, so they both have a name property. As far as TypeScript is concerned, they are the exact same type. So I have Harry and Dobby, who are my person and my elf. By the way, if I could just get several people are typing for Harry Potter references, that will make me happy. And if I call this function getPersonName on a person, it's going to work just fine because they're structured the same. I'm not going to have any errors when I do this. But if I add a property to person, let's say I add this wand property, it's going to complain immediately because it is missing a parameter on type person. We can also use structural types to derive other types, which is pretty cool. So let's talk about intersection types. So let's say I have my person and my spellcaster now, more HP references, and I can do an AND on them to combine these two types into one type that contains both of them. So in this case, wizard, which is of type person, and spellcaster is the combination of the two. Thank you so much, Matt, for the Harry Potter gif. I appreciate it. And if I do this in runtime with person and spellcaster, I can splat over the person and splat over the spellcaster, and it's going to produce that wizard for me. Similarly, we have union types where we can have a wizard, which has name and string, name and spells. Spells is an array of strings. And then we can have a muggle. Muggles can't cast spells, and muggles are people too. So we have type person, is wizard or muggle. And I made this function called say my name, and it returns the person's name. And this works just fine because we are using the one shared property, which is name, and we're keying into it. If I needed to get more advanced and figure out, is this person a wizard? I could make a type guard function, which can take a person and then return a Boolean, whether or not that person is of the type we expect it to be, which in this case is a wizard. Now, it's worth noting, this is kind of a runtime type assertion. If you've ever used the as keyword in TypeScript, it's very similar to that, but it's allowing us to be a little more methodical about when we're just saying, hey, I'm very confident about what type this is. Total sidebar, when I made the same my name function, I tried really, really hard to find a GIF of Beyonce as a wizard, and then I stumbled upon this horrifying thing, which I just never want to see ever again. So we're going to move on. I never want to see that. But also, never is a type. And even if you've never used TypeScript, how many of you have left this comment in your code? This should never happen, right? So never is a type that allows us to tell TypeScript, hey, I expect you to break. Let's look at the ergonomics of that. So let's say I have this assert exhaustive function, right, which takes never. So anything that's passed to this will break type checking and returns never. So if this function is ever returned from somewhere, it's going to also break type checking. So I have a test exhaustive function, which has an enum over wizards, which right now is Harry and Hermione. And the default case is assert exhaustive. And if it ever gets to this line, this function is now going to return never, and it's going to break. It's also going to be taking wizard, which better not be of type never. So if I go and add a third type to this enum, it's going to complain because it knows I'm trying to assign wizards.ron to type never. And what's cool about this is you can imagine that we probably have this enum, deeply nested in some side of our code base, and then we have the actual function that's using it on the other side of the code base, and two engineers who never talk could both be modifying this code, and it'll catch these types of errors, which is very cool. Now, never and unknown have some really interesting transitive properties. So if we look at a number and something that should never, ever happen, well, it's going to turn out to be something that should never, ever happen. That's what that intersection works out to. But if we look at a number or something that should never, ever happen, or string or null, etc., it's going to produce the type that can actually happen. Unknown is the opposite. So if we do the intersection of a number and the set of all possible types, it's going to produce a number. But if we say, hey, this could either be a number or the set of all possible types, it's going to be the set of all possible types. These properties hold up with when you use never and unknown against each other. So never and unknown is never, and never or unknown is unknown. But any ruins everything. In fact, for the few Harry Potter fans in the audience, any just like cobblers everything up. It's Polyjuice Potion. It's just terrible. I actually went to go see what does any do against never and unknown. Interestingly enough, the one time any fails is when you do the intersection of something that should never ever happen and any. And I have no idea why. So if you do, please let me know. Cool. So we're going to move on to generics, which is the namesake of this talk. I am very excited about generics, so I am going to bring in a GIF of my girl Tay, because this is my feeling when I talk about generics. And generics are like passing a type as an argument. Okay? So let's look at a basic example. So we have this identity function, which takes an argument and returns it. But also in the type layer, it's taking t, the type, as an argument, and it's returning a value of type t. So if I give it a string, it'll return a string. If I give it an array, it'll return an array. And if I give it a number, it'll return a number. Now we can combine these with some of the features we talked about earlier. So I have my person and my elf now, right? Which with my name and one, and just name on the elf. And now spellcaster, instead of being its own type, is going to be a generic type that does t intersected with this object spells of string. So it adds spells to the object passed to it. So now when I produce wizard and house elf, it's going to compile down to spells and person or spells and elf, and it'll produce this object in total with all of these properties. Now, that's a little contrived, but you're actually likely using these in the real world if you're using TypeScript. So for example, let's say you have a React component. When you give it the props on that component, that's a generic. When you say, hey, this is what this promise resolves to, that's also a generic. We're passing that number as an argument in the type layer. We can add constraints to our generics, which is pretty cool. So a lot of the time we want to say, we only want to be able to pass like one of these few types. So back to my person and my elf, I just keep using this example. Now my spellcaster, however, has this constraint. T extends person. And if this doesn't evaluate to true, my type checker is going to complain. So when I do spellcaster of person, it's just fine. It produces the wizard. But if I try to create a magic carpet, which I'm very proud of this line, I thought it was clever, it's going to complain. Type string does not satisfy the constraint person. Similarly for house elf, this is the exact same error when we tried to pass an elf to that get person name function when it was missing a property. So it's telling us exactly what property is missing and why it doesn't match this constraint. Let's go to the next layer. We also index in the type layer, and then we can do it with generics. So I give another talk on types, on code splitting a typed Redux store. And I probably spent 10 minutes in that talk on this slide, but we're going to give a rough overview of it. So let's say I have this Redux state, which has people and elves, right? I can look at the key people similarly to how I would in a real object in JavaScript, and it'll return a type for me. So it allows me to index into the type layer. And then I can use a generic and do that with a variable type. So I have this function called getKey from Redux store, and it takes the type Redux state, which is these people and these elves. And now I have a generic t extends key of Redux state. What is key of Redux state? Well, that is a union of all the keys on Redux state. So we're now saying that this key has to be one of the keys inside of the object that's given to it. And it's returning a type of one of the values on that object by doing redux state at t, which will be whatever key we're looking for. Just pretty cool, in my opinion. So a lot of that was type narrowing, where it's I want the compiler to figure out what type we have. But sometimes we want to go from type A to type B. I'm rewatching Doctor Who right now, so I'm just like really into the Doctor Who gifs. So map types are an interesting case for these. So we can do loops in the type layer as well. So these two functions, partial and pick, are very popular in TypeScript. And you can see here we're doing p in k, or key of t. So we are looping over something in the type layer. So I want to look into how each of these work. We'll start with partial, and then we'll do pick. So I work for Dropbox. We think about files a lot. And let's say we want to have all the properties on a file be optional, right? Like maybe we have the name at the beginning, but then we need to go fetch the size and permissions of the file. So partial makes all of these properties optional. The way this works is partial takes a generic, it takes an object, a type, and then it produces key of that type inside of it, which in this case is going to be name, size, and permissions. So we are going to loop over that, where p is each of those. We make it optional, and then we index in the type layer and return that type at that index. Let's look at one more example of this. Pick is a function that allows us to get a subset of the properties on a type. So we pass it file, and then we say we want name or size, and it gives us just the subset of those properties. This works very similarly. It takes t, which is a generic. But now we're producing that array that we're going to loop over in the type signature, because we have to have that constraint, k must be one of the keys of there. And we're doing that in the signature. So before we were doing it in the body, now we're doing this up in the signature. We're looping through k, p in k, and then we index into the type layer again and return the specific type. Now, I know that was a lot of advanced TypeScript, and yeah, my brain was pretty fried the first time I gave that. So I just want to give everyone a mental rest. Can y'all just start posting GIFs in the Slack channel with any of your favorite things? I don't care what. Just post some GIFs, give your brain a break, because we're going to move on to some even more advanced TypeScript shortly. Cool. I'm like waiting for the catch-up to happen. Yes, thank you, Dan. Cool. Conditional types. So we can have types and perform if-else logic in the type layer. So I have this type, number or null, and it takes my generic, and now we have a constraint, t extends number. And if this predicate evaluates to true, it's going to return a number, otherwise it's going to return null. So if I give it a number, it returns number. If I give it a string, a boolean, or even null, it returns null. And we could do some pretty cool things with this. So we could say, hey, I need the type. I need either the promise of a type or the type inside of it. And we can say this is either going to extend the promise and it's going to return the promise, or it's going to be never. Sorry, I skipped ahead. So in this case, we're saying, hey, this is either a promise of anything, and we return the promise of anything, or we return the type inside of it. But that's kind of weird, right? Because like this is the set of all possible types, and maybe we want to actually get the type out from inside the promise. And this is where we use one of my favorite features of TypeScript. This is called Inference Types, and this is the last thing we're going to cover. And I like to think of Inference Types as what's in the box. So we have a type now called unwrap promise. We have the same constraint t extends promise, but now we have infer a. And what this does is, as long as t extends promise, it's going to return the type inside of that promise. Otherwise, the type checker will break. So when we look at a promise of string or number, and we go to unwrap the promise, it's going to give us that inside type. If we give it something that isn't a promise, it's going to fail the check, and it's going to break in the type layer. It's going to return never. We can use this for other things too. Like we can get the arguments of a function. So we can say, hey, if t extends a function, we can infer the arguments of it and return them. So let's see with the argument, or we break the type checker. So when I give it this function that takes A and B, it's going to return a tuple of type number and string. We can do this in React as well. I had to have one more Taylor Swift reference. So assuming that it is of type React component, we can infer the props. So now it'll return the props, break the type checker. And if we give it a Taylor component, we have the list of albums as props. And this is effectively a function that gets those props out of the component in the type layer, which in this case will return albums. So let's review, shall we? Because we just covered a lot. We covered structural typing, where two types are the same. We covered never, where we can tell TypeScript that something broke. We covered unknown, where we can say, hey, I don't know what type is here. We covered unions, where we can look at type A or type B. We covered intersections, where we're combining types. We covered generics, where we're using types as arguments. We covered indexing. We covered map types. We covered conditional types and inference types. And that is way too much. I don't expect anyone to actually remember all of that. Here's what I hope for you. Here's a slide of everything we covered today. This is what you can Google when you are digging into TypeScript code, and you now have an overview of these things. Here's what I actually want you to take away from this. I want you to avoid any at all costs. I want you to start with unknown and see what happens. And I want you to use never to tell TypeScript that something is broken. So thank you so much. My name is Matthew Gerstman. And I think we can move on to questions. We have a few minutes for those.
Hey, thank you, Matthew. That was pretty awesome.
Thank you.
And I also like the Harry Potter references in there.
Always for my own amusement.
So a little philosophical there. Start from the unknown and see what happens.
Yeah, a little bit.
So what are some of the disadvantages of TypeScript? You gave us a really good picture of what's awesome about it, and I love it. But what are the things we should be careful about?
So if you're new to TypeScript, which this was very much not aimed at those people, the biggest thing I will tell you is that TypeScript will get in your way for the first few months, and then it will quickly turn into something you can't live without. So there's a lot of stuff where just like it's telling you in your editor what is and isn't broken. But when you're first figuring out how to type these advanced patterns, or you're like the first time you dig into a library and you have to look at all these generics or all these crazy features, you're just like, what is going on here? So it's really the learning curve is the worst part of it. I have no other complaints about TypeScript, actually.
Okay, that's awesome. TypeScript compiles down to JavaScript, right?
Yeah, so TypeScript is a superset of JavaScript. It supports compiling down to ES6, ES5, or even ES3. There's a whole bunch of flags. Sometimes people use it with or without Babel, depending on what they're looking to do. But yes, it runs in the browser as JavaScript.
Okay. Is there some mismatch between TypeScript and JavaScript in that case, where maybe TypeScript compiles down to something that doesn't quite directly match with JavaScript? Is that still the case, or?
So it's funny. So theoretically, and for all practical purposes, the answer to that is TypeScript always compiles down to exactly equivalent JavaScript. So TypeScript is a superset. It's not really like CoffeeScript where there's different syntax. It is the exact same thing. Now, I say this with an asterisk on it because, funnily enough, a security engineer at Dropbox found the one case where you have valid TypeScript that produces something different in JavaScript, but that is a bug, not so much a feature. So let's go with 99 point a lot of nines on a yes.
Well, that's good. That's good to know. Excellent. Were there things that you wish TypeScript did not have?
Interesting. So there's both interfaces and types. I personally lean towards types. I don't think it's very clear to people when to use which one. I think that's the biggest thing where it's like people are like, I don't know which feature to use here, and I still don't know which one to use most of the time. There's a great book I read called Effective TypeScript, and it pretty much, the guidance in there was pretty much use whatever your code base started with. So I guess I'd probably kill one of those if I had to pick.
Yeah, well, so I do agree with what you're saying. It did throw me a little bit off, especially with Angular. Interfaces are so important, and to a great extent, I would say TypeScript having interfaces kind of favors the Angular way of developing things, but it can get a little confusing as to like, why would I need it? So yeah. Excellent. Well, that was an amazing talk. Really enjoyed it. So thanks for your time. Let me check really quickly if there's any more questions. I don't see any more questions. So thank you so much. Appreciate it.
Cool. Thank you so much.